Hi everyone, it's Mrs. Griffin with the Unit 8 Lesson 4 video about some of the other properties that chords can have when we're dealing with chords in circles. So take a moment, pause here, and do the opening exercise, and then I'll post the answers. And on to the notes. So 3 rules we're going to talk about in this lesson. The first is what happens when we have chords that are parallel. And so if I were to sketch in 2 chords and make them parallel to one another, so I have a chord here and here, and parallel means that they will never touch, then the arcs between them here and here are going to be congruent. So parallel chords cut congruent arcs between them. Okay. Next, if I have 2 congruent chords, so I have one chord here and I have another chord here, and they happen to be the same length. If those chords are congruent, then the arcs outside of them are congruent. Okay, and then finally, if I have a chord that's perpendicular to a diameter, so here's my chord and my diameter. If those are perpendicular to one another, then the chord and the arcs are all bisected. Okay, so some of these rules might apply. The rest of the examples in this may or may not use those rules, but they're all practice with everything we've been doing up until this point. So if we look at number 1, we have these 2 chords that are marked congruent. That means that the arcs are going to be congruent as well. So when I want to find out what arc 2 is, I can do 360 minus 116 and then divide that by 2 to get 122 for arc 2. And then angle 1 is just an ordinary inscribed angle, so it's half of the 116, which would be 58 degrees. Number 2, we have parallel chords. That means that the arcs between them would be the same. So if this one's 70, so is this one. Angle E is inscribed to that 70, so it will be 35. Okay. For number 3, you can see that these 4 pieces are marked congruent. That means the entire chords are congruent. So because of those chords being congruent, that means these arcs are congruent as well, and B would also be 80 degrees. Okay, when we look at number 4, the 2 congruent arcs would mean that the chords out here and here would be the same. And we have this 58 degrees, so that's an inscribed angle. If I double that, 58 times 2 is 116. And then subtract from 360, divide that by 2, and these other 2 arcs have to be 122 degrees each. Okay, now, using that, the 116 and angle 1 would be half of 116, which is 58, because the vertex is on the circle. And then angle 2 is a little tricky. If I were to look at the fact that I have an isosceles triangle here, based on the fact that those are 2 radii, I can take the 116 and put it in here, and then use the isosceles triangle to find these 2 angles. So 180 minus 116 divided by 2 means that this angle would be 32. I also now have to use the fact that angle 2 is part of this inscribed angle. So these 2 together have to be half of the 122. So 122 divided by 2 is 61, and then I'll subtract out that 32 I found from the isosceles triangle to get that angle 2 is 29 degrees. Number 5, I have these 2 arcs marked congruent. I have an 18 and a 28. Both are inscribed. If I follow the 18 out, it would be half of this arc, making that one 36 as well as this one. If I follow the 28, that would make this arc 56, and now I have almost all the arcs. So if I subtract all of these arcs from 360, I'll find that the missing arc here is 142. And then angle 1 and 2 are just inscribed angles. So angle 1 would be inscribed to all of this together, which is 72, and therefore would be 36 degrees. And then angle 2 is half of the 142, so that would be 71 degrees. Okay. For number 6, I have parallel lines again. That means I have congruent chords again. If this angle is 10 degrees, then this arc would be 20, and therefore so would be x. For number 7, all 3 of these are marked congruent, so I'm going to make them all 40. And since all the arcs are given except for this last one here, I'm going to add them up and subtract from 360 and find that that arc is 131. Angle 1 is inscribed to that 131, so it's half of it. Half of 131 is 65.5. And angle 2 is inscribed to the 109, so it's half of the 109, which should be 54.5. Okay, in number 8, notice we have the right angle. Because of that, the radius making a right angle with the chord, it not only bisects the chord, but it also bisects the arcs. Since the 70 is a central angle, this arc would be the same, and so would this one. And we want to find n, that means we have to subtract the two 70s from 360. So 360 minus 140 is 220. For number 9, again, we have parallel lines, parallel chords, so the arcs are congruent. So if this inscribed angle is 35, this arc would be 70, and this arc would be 70. So they want us to find CE, BD, and ED. So CE we just found is 70. BD we just found would also be 70. And then to find ED, this one, notice that what I have here is a diameter. That makes this a semicircle. So all three of these would have to add up to 180. So 180 minus 70 is 40. Okay, on to number 10. These two pieces are marked congruent as well. So when I look at the 18 degrees here, that's inscribed. If I follow that out, this arc would be 36, and so would this one. Okay, and if I follow this inscribed angle, the 30 out, I would be able to figure out that this arc would be 60. Now, angle 1 goes from here all the way to here, so it's a central angle. It's the same as all of those added together. So if I add all those together, I get 132 degrees. All right, and then angle 2 is just a regular inscribed angle to the 36, so it's also going to be 18, just like angle 1. I'm sorry, just like the first angle given. All right, in number 11, in circle A, BC is a diameter. So because BC is a diameter and we have a tangent here, we know we have a right angle. Because anytime a diameter or a radius meets a tangent line at its point of tangency, it forms a right angle. And since these are parallel, that means by alternate interior, this is also a right angle. Therefore, the chord is bisected and the arcs are bisected. Then they're telling us arc CE is 68. Well, that would mean that CD is also 68. Since this is a semicircle, we would do 180 minus 68 if we wanted to find arc BD. 180 minus 68 is 112 for both of them. All right, now to find what they want. They wanted arc CD, which I just found. That was the first thing we did. They want angle DBE. So angle DBE is here. It's an inscribed angle to this arc out here. So if I put the two 68s together and then divide it by 2, 68 times 2 is 136, and then divide it by 2 is also 68 degrees. Each one of these would have been 34 if you wanted to do them individually. Okay. Also, they want angle DCE. And there's a few ways you can do that. You can do the same thing with the inscribed angle, or you can realize this is a quadrilateral that's inscribed, and so opposite angles would be supplements. And so you can do 180 minus 68, which would get you 112 degrees. Okay, and lastly, number 12. I like this example because the picture and the answers do not look at all correct. But here we go. So we have that the measure of arc CB equals the measure of arc ED, that arc BC to BD to EC are in a ratio of 1 to 2 to 4. So we're going to do 1x, 2x, and 4x. So BC will be 1x. That means that so is ED. BD would be 2x, and EC would be 4x. And all of those arcs would have to add up to 360. So if I add them up, 4, 5, 6, 7, 8x would equal 360, and then when you divide by 8, you're going to get 45 degrees for every x. So now I can substitute that in. This would be 45, this would be 45, this would be 90, and this would be 180, which it clearly doesn't look like, so that's why I like this problem, so that you remember you can't trust the picture. Okay, and then they want us to find angle BCF, angle EDF, and angle CFE. So BCF, that would be this one. BCF is the same as BCD because it is a line, so we're going to do an inscribed angle to the 90, so it's going to be half of the 90, which would be 45. EDF is the same as EDC, so that's an inscribed angle, and it would be half of that 180, and therefore it would be 90, even though it doesn't look like it. And then finally CFE. CFE is the exterior angle to this triangle. So if I were to look at that as exterior angle theorem, this angle that I'm looking for would be equal to not the one next to it, but the other two added together. So if I can find angle B, which is also inscribed to that 80 and therefore is also 90, then I can figure out, using the triangle, my exterior angle theorem, 90 plus 45 is 135. And the picture totally looks wrong, and that's okay because you don't trust the picture. Alright, so there's some review, practice, and some new concepts that have to do with our chords. I will see you in class.